Hello, in this lecture I'll answer 2 questions. In the first question, we find out the radius of this circle, and in the second question, we find out the area of this green shape. So we start with the first question. In the drawing, we have a circle. From this common point A, we have 2 tangents to this circle, tangent AP and tangent AQ. We have also a third tangent. This is tangent BC. This is tangent to this circle at this point. So we define the point of tendency of tangent BC with this circle, this point M. We define the center of this circle, this point is point O. We define the radius of this circle as R. R is the radius that we are looking for in this question. In the next step, we join points O and Q together by straight line. Point Q is the point of tendency of tangent AQ with this circle. Point O is the center of this circle, point Q is the point of the circle itself, therefore OQ is the radius of this circle. This is equal to R according to our definition. The radius OQ is equal to R, the radius OQ is drawn to point Q, that is the point of tendency of tangent AQ with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees, according to rule 1. Point P is the point of tendency of tangent AP with this circle. So we join points O and P together by straight line. OP is of course the radius of this circle, that is equal to R. The radius OP that is equal to R, the radius OP is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle also equals to 90 degrees according to the same rule, rule 1. We define the length of this tangent PB as X. Here we can implement rule 2. Implementation of rule 2. According to rule 2, the lengths of 2 tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint, point P. From this common standpoint, point P, we have 2 tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. In our drawing, we focus at this common standpoint, point B. From this common standpoint, point B, we have 2 tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But BP equals to X, therefore BM must be also equal to X units in its length. What is the length of this missing line segment MC? MC equals to BC minus BM. MC equals to BC minus BM. So now MC equals to BC minus BM. So MC equals to BC. BC equals to 14 units in itself according to what is given in the question. BC equals to 14. BC equals to 14 minus BM. BM equals to X. So in total, we found out that the missing 97 MC equals to 14 minus X units in itself. MC equals to 14 minus X units in itself. So in the next step, we focus at this common external point C. From this common external point C, we have two tangents to this circle. Tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But CM equals to 14 minus X, therefore CQ must also equal to 14 minus X units in itself. In the next step, we will join points A and O together by a straight line. By joining points A and O, we can deduct those two right angles. This is the upper right angle APO, and this is the right lower triangle OQA. So what is the area of this big quadrilateral APOQ? The big quadrilateral APOQ consists of those two components, and therefore the area of this big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. So it is now, if we found out that the area of this big quadrilateral APOQ but before that, we'll focus on this common external point A. From this common external point A, we have two tangents to this circle, tangent AP and tangent AQ. And according to rule 2, they are equal to each other. That is to say, AP equals to AQ. And again, according to rule 2, tangent AB equals to tangent AQ in its length. AP equals to X plus 16. And it equals to AQ. AQ in total equals to 18 plus 14 minus X. And again, AQ in total equals to 18 plus 14 minus X. So we know that X plus 16 equals to AP equals to AQ equals to 18 plus 14 minus X. 18 plus 14 is 32. So total this expression equals to 42 minus X. Those two sides of the equation are equal to each other. That is to say, X plus 16 equals to 32 minus X. Here we'll add X to this equation. Here X plus X is 2X, so here we have, in the side of the equation, we have 2X plus 16 equals to 32. Here we'll subtract 16 from this equation, and we get that 2x equals to 32 minus 16 is 16. So 2x equals to 16. Here we'll divide this equation by 2. And finally we get that x equals to 16 over 2 is 8. X equals to 8 units in its length. this is tangent PB equals to x and x equals to 8. Likewise, we have here BM also equals to x and x equals to 8. Here we have last set MC is equals to 14 minus x. 14 minus x is 14 minus 8, that is 6. Likewise, QC also equals to 14 minus x, that is actually 6. So, we actually join points A and O together by side line. By joining points A and O, created those two right triangles. This is the upper right triangle OPA. This is the lower right triangle OQA. So, as we mentioned before, the area of this big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. So, you know, the area of the big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. The first component is the right triangle OPA. So it is the area of the first component. It means that it is the area of this right triangle OPA plus the second component that quadrilateral APOQ consists of. This is actually the area of this lower right triangle AQO. So in total, we should know that the area of the big quadrilateral APOQ, this big quadrilateral APOQ, according to the first method of calculation, must be equal to the sum of the areas of the two components that it consists of. Triangle APOQ consists of those two right triangles, and therefore is equal to the sum of the areas of those two right triangles. Is equal to the area of the upper right triangle OPA plus the area of the right triangle AQO. So what is the area of this upper right triangle APO? Must be equal to the base AP times the height to the base, that is PO, over 2. And again, the area of this upper right triangle APO, it is equal to the base AP times the height PO over 2. Plus the area of the second component that quadrilateral APOQ consists of. The second component is this right triangle AOQ. The area of this right triangle AOQ equals to the base AQ times the height to the base QO over 2. Okay, again, the area of this lower right triangle OQA, in total it is equal to the base AQ times the height to the base QO over 2. AP equals to 16 plus 8, that is 24, times PO. PO is the radius of this circle, that is equals to R. R is the radius that we are looking for in this question. So AP is 24, PO is R, divided by 2. So in total, we should find out that the area of this upper right triangle OPA is equals to 24 R over 2. So it's in size. Plus the area of the second component that quadrilateral APOQ consists of, the area of this right triangle, right lower triangle AOQ. And the area of this right triangle AOQ equals to the base AQ. AQ is 18 plus 6, that is 24, times the height QO, that is R over 2. So total we found out that the area of the right lower triangle AQO equals to the base, that is 24, times the radius, that is R over 2. So in total we found out that the area of the big quadrilateral APOQ equals the area of the big quadrilateral APOQ according to the first method of calculation equals to 24 R over 2 plus 24 R over 2. So 24 R over 2 is 12 R, 12R plus 12R is 24R. So according to the first method of calculation, they have the big quadrilateral APOQ is equal to 24R squared inside. And again, the area of this big quadrilateral APOQ is equal to 24R squared in size. In the next step, I will delete this straight line AO. And we'll join points O and M together by straight line. Point M is the point of tendency of tangent BC with this circle. So we join points O and M together by straight line. Point O is the center of this circle, point M is the point of the circle itself, therefore OM is the radius of this circle. This goes to R. The radius OM, this goes to R, the radius OM is drawn to point M, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to rule 1. In the next step, we join points O and B together by straight line. And we join points O and C together by straight line. When doing those constructions, you can do 4 right angles. 1, 2, 3, 4. So the next step, we calculate the area of each right angle separately, and then we let the areas together. What is the area of this right angle OPB? The area of this right angle OPB equals to the base PB, that is 8, times the height PO, that is R over 2. So total, the area of this right angle OPB equals to 8R over 2. 8R over 2 is 4R. The area of this right angle OPB equals to 4R squared in size. What is the area of this right angle MOB? The area of this right angle MOB equals to the base MB, that is 8, times the height MO, that is R over 2. So total, the area of this right angle MOB equals to 8R over 2, that is also 4R. What is the area of this right angle COM? The area of this right angle COM equals to the base CM, that is 6, times the height MO, that is R over 2. So in total, the area of this right angle CMO equals to 6R over 2. 6R over 2 is 3R. 3R squared in size. And finally, what is the area of this right angle QOC? The area of this right angle QOC equals to the base QC, that is 6, times the height QO, that is R over 2. So in total, the area of this triangle QOC equals to 6R over 2. 6R over 2 is 3R. So in total, the area of this 4 right angles is equal to 4R plus 4R is 8R, 8R plus 3R is 11R, and 11R plus 3R is 14R. So in total, the sum of the areas of those 4 triangles is equal to 14R squared in their sizes. In the next step, we calculate the area of this big quadrilateral APOQ according to the second method of calculation. The area of this big quadrilateral APOQ will be equal to the sum of the areas of those two areas. It's actually 14 are shown in their sizes, plus this green triangle ABC. Plus this green triangle ABC. Please again, according to the second method of calculation, they have this big quadrilateral APOQ. Is equal to the sum of the areas of those four areas, that's actually 14R, plus the area of this green triangle ABC. This is the area of quadrilateral APOQ according to the second method of calculation. We already found out that the area of this big quadrilateral APOQ according to the first method of calculation is equal to 24 R squared in size. So we have to find out the area of the green triangle ABC. The area of this green triangle ABC. We use a new formula in order to find out the area of this green triangle ABC. Here triangle ABC could be any triangle. It is a general formula for the area of any triangle. So triangle ABC in this equation could be any triangle. So the area of triangle ABC that could be any triangle is equal to the following equation. The following formula is equal to the square root of S times S minus A times S minus B times S minus C. We can use this formula in order to find out the area of a triangle. In this formula, S is the semi-perimeter of the triangle, that is area we are looking for. The semi-perimeter of any triangle is equal to the perimeter over 2. The perimeter of any triangle is the sum of the side lengths of the triangle. In our triangle ABC, it is 16 plus 14 plus 18. The perimeter of our triangle ABC is equal to the length of this side, that is 16, plus the length of this side, that is 14, plus the length of this side, CA, is equal to 18. If we divide the perimeter by 2, we get the semi-perimeter of our triangle ABC. So the perimeter in total equals to 16 plus 14, that is 30. And 30 plus 18 is 48 over 2. 48 over 2 is the perimeter of this triangle ABC. 48 over 2 is 24. So in total we found out that the semi-perimeter of our triangle ABC is equal to 24 units in its length. So now, S of our triangle ABC is equal to 24 units in its length. In this formula, A, B, and C are the side lengths of the triangle, that its area we are looking for. Now triangle ABC, in our triangle ABC, we choose A as 16, we choose B as 14, and C is 16. C is 18. And C equals to 18. So C equals to 18. So we have all the data that is needed in order to find out the area of this triangle ABC. We just have to put the data of this triangle ABC inside this formula. There are formula for the infinite triangle. In this way we find out they have this green triangle, triangle ABC. So we do now we get that the area of the green triangle ABC is equal to the square root of S is 24, times S minus A. S minus A is 24 minus 16, times S minus B. S minus B is 24 minus 14, times S minus C. S minus C is 24 minus 18. So therefore our triangle ABC, in total it is equal to square root. Inside the root we have 24 times 24 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 18 is 6. So in total we found out that the area of this green triangle ABC is equal to the square root of 24 times 8 times 10 times 6. Actually the value of this expression is 107.33 square root in size. So I actually found out that the area of this green triangle ABC is equal to 107.33 square root in size. So we can substitute in this equation the area of triangle ABC by 107.33. We do it now, we get that the area of the big quadrilateral APOQ according to the second method of calculation is equal to 14R. This is the sum of those four right triangles. Plus the area of this triangle ABC is equal to 107.33 square root in size. This is plus 107.33. So the area of triangle ABC, the area of quadrilateral, the big quadrilateral APOQ, according to the second method of calculation, in total is equal to 14R plus 107.33. This is according to the second method of calculation. When according to the first method of calculation, we only found out that the area of the same quadrilateral APOQ is equal to 24 R squared in size. So we have two different equations for the area of the big quadrilateral APOQ. Therefore, we get equation 3 that says that the area of the big quadrilateral APOQ, according to the first method of calculation, must be equal to the area of the same quadrilateral APOQ, according to the second method of calculation. So the area of the big quadrilateral APOQ, according to the first method of calculation, is equal to 24R, and it must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. The area of the big quadrilateral APOQ according to the second method of calculation equals to 14R plus 107.33. So in total we found out that according to equation 3, 24R equals to 14R plus 107.33. So here we subtract 14R from this equation, and we get that 24R minus 14R is 10R. So 10R equals to 14R minus 14R is 0, so we have to only 107.33. This I do the equation. So here we divide this equation by 10. If I get the radius of this circle, that is the radius that we are looking for in this question, the radius R equals to 107.33 over 10 is 10.733 units in itself. And puis again, we found out in total that the area the radius of this circle is equal to 10.733 units in itself. So finish to answer the first question. The next step, we present you the second question and answer the second question in the next lecture. In the second question, our task is to find out the area of this green shape. So in the drawing, we have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have this rectangle. According to what is given as the question, the area of this rectangle is equal to 4 square inches in size. And we also have this quarter circle. Again, our task is to find out the area of this green shape. So first of all, we will define the length of this rectangle, this side as x, and we will define the width of this rectangle, this side as y. We know that the area of any rectangle equals to the length times the width. Therefore, the area of this rectangle equals to x times y. And it is given as a question that the area of this rectangle is 4. So x times y equals to 4. But we also know that the opposite sides of the rectangle are equal to each other. So in this rectangle, those two opposite sides are equal to each other. But this side equals to y, therefore this opposite side must be also equal to y units in itself. This is a quarter circle, and those two sides are defined as the area of the quarter circle, therefore they are equal to each other. But this radius equals to y, therefore this radius was also equal to y. Actually, those two line segments are not look that they are equal to each other, but the problem is with the drawing. The problem is with the drawing. So you should those two sides are equal to each other, and the problem is with the drawing. Okay. So what is the diameter of this biggest semicircle? The diameter of this biggest semicircle is x plus y. Therefore, the radius of this biggest semicircle equals to x plus y over 2. So until now, the radius of the biggest semicircle is equal to x plus y over 2 units in its length. What is the radius of this medium semicircle? The radius must be equal to the diameter that is x over 2. So the radius of this medium semicircle equals to x over 2 units in its length. So the radius of the medium semicircle equal to x over 2 units in its length. And finally, what is the radius of this smallest semicircle? The radius must be equal to the diameter y over 2, which is y over 2 units in its length. So the radius of the smallest semicircle is equal to y over 2 units in its length. So in total, we found out that the radius of the biggest semicircle equals to x plus y over 2, the radius of the medium semicircle equals to x over 2, and the radius of the smallest semicircle equals to y over 2 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? From the domain, it is very easy to see that the area of the green shape in total equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. Repeat again, the area of this green shape is equal to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. So it is now the area of the green shape equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. We already found out that the area of the biggest semicircle equals to x, the radius of the biggest semicircle equals to x plus y over 2 units in its length. The radius of the medium semicircle equals to x over 2 units in its length. And finally, the radius of the smallest semicircle equals to y over 2 units in its length. So what is the area of the biggest semicircle? Actually, the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of the biggest semicircle must be equal to pi over 2 times the radius of the biggest semicircle squared. That is to say, it is x plus y over 2 squared. Minus the area of the medium semicircle. So the area of the medium semicircle must be equal to pi over 2 times the radius of this medium semicircle squared. That is to say, it is x over 2 squared. Minus the area of the smallest semicircle. The area of the smallest semicircle must be equal to pi over 2 times the radius of this smallest semicircle squared. It's actually y over 2 squared. So if you found out that the value of this expression is the area of the green shape. So we just simplify this expression, and this way we find out the area of the green shape. So here we have pi over 2 times x plus y over 2 squared. X plus y over 2 squared equals to x plus y squared over 2 squared. 2 squared is 4. We have here minus pi over 2, x over 2 squared equals to x squared over 4. Minus pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. So here we have 8 in the denominator of all those three expressions. So we take 8 as a common factor out of those three expressions. So in the denominator we have 8. In the denominator we have here pi times x plus y squared. Minus, in the denominator we have minus pi x squared. Here we have minus pi y squared. Here we'll open the brackets of this expression. We get that pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y. Minus pi x squared minus pi y squared. So we'll open the brackets of this expression and we get that we have here pi times x squared plus pi times y squared plus 2 pi xy divided by 8. Here we have minus pi x squared minus pi y squared. So in the denominator we have pi x squared minus pi x squared is 0, so those two expressions will get cancelled. Likewise, we have pi y squared minus pi y squared is 0, so those two expressions also will get cancelled. So in the denominator we are left only with 2 pi xy divided by 8. Here we divide both the numerator and the denominator of this expression by 2. 2 over 2 is 1, so left in the denominator we left only pi xy divided by 8 over 2 is 4. So today we found out that they have the green shape equals to pi times xy over 4. We already found out that xy equals to 4, so we substitute xy here by 4. We get that it is pi over 4 and xy is 4. We have 4 in the denominator, 4 in the denominator, so 4 will get cancelled and left only with pi. So today we found out that they are the green shape, that is the area that we are looking for this question. Is equal to pi square root in size. Okay, again, if you found out that the area of this green shape is equal to pi square root in size. So we finish to answer the second question. In the next step, observe the direction. This is to say, we repeat on the solution of the first question and then we repeat on the solution of this second question. In the first question, our task is to find out the radius of this circle. So in the drawing we have a circle. This is the common extent point A. On this common extent point A, we have two tangents to this circle, tangent AP and tangent AQ. In addition, we have a third tangent BC, tangent to this circle at this point. So we define the point of tendency of tangent BC with this circle. This point is point M. BC equals to 14. Tangent BC equals to 14 units in Islam. AB equals to 16 units in Islam. AC equals to 18 units in Islam. And our task was to find out the radius of this circle. So as I mentioned before, we define the point of tendency of tangent BC with this circle. This point is point M. We defined the center of this circle. This point is point O. We define the radius of this circle as R. Point Q is the point of tendency of tangent Q with this circle. In the next step, we join points O and Q together by side line. Point O is the center of this circle. Point Q is the point of the circle itself. Therefore, OQ is the radius of this circle. That is equals to R. The radius of Q is equals to R. The radius of Q is drawn to point Q. That is the point of tendency of tangent Q in this circle. And whenever your radius is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees according to rule 1. Point P is the point of tendency of tangent AP with this circle. So we join points O and P together by side line. OP is of course the radius of this circle. That is equals to R. The radius OP is equals to R. The radius OP is drawn to point P. That is the point of tendency of tangent AP with this circle. And whenever your radius that is drawn to the point of tendency, whenever your radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to rule 1. In the next step, we define the graph of this tangent BP as X and implemented rule 2 in our drawings. So please click on rule 2. According to rule 2, the lengths of two tangents from a common standpoint per circle are equal. In the drawing, we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, this whole rule 2 are equal to each other. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. Why? In our drawing, if we focus this common standpoint point B, from this common standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But BP equals to X, therefore, according to our definition, therefore BM must be also equal to X units in itself. What is the length of this missing line CM? CM equals to BC minus BM. Again, CM equals to BC minus BM. And again, MC or CM equals to BC minus BM. So, CM equals to BC, that is 14, minus BM, that is X. So, in total, we found out that the missing line side MC equals to 14 minus X units in its length. In the next step, we focus on this common sum point C. From this common sum point C, we have two tangents to this circle, tangent CQ and tangent CM. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But CM equals to 14 minus X. But therefore, CQ must be also equal to 14 minus X units in its length. In the next step, we focus on this common sum point A. From this common standpoint point A, we have two tangents to this circle, tangent AB and tangent AQ. According to rule 2, they are equal to each other. That is to say, AP equals to AQ. And again, according to rule 2, tangent AP equals to tangent AQ in its length. AP in total equals to 16 plus X. AQ in total equals to 18 plus 14 minus X. And again, AP equals to 16 plus X and AQ in total equals to 18 plus 14 minus X. 18 plus 14 is 32, so this expression in total equals to 32 minus X. Those two sides of the equation are equal to each other. That is to say, X plus 16 equals to 32 minus X. X plus 16 equals to 32 minus X. So here we added X to this equation and found out that X plus X is 2X. So here we have 2X plus 16 equals to 32. X minus x is 0. So 2x plus 16 equals to 32. If we subtract the 16 from this equation, we found out that if we have to leave 2x equals to 32 minus 16 is 16. So in total, if we found out that 2x equals to 16, if we divide this equation by 2, we found out that x equals to 16 over 2, that is 8. This is nice tangent PB, equals to x, and x equals to 8. Likewise, BM also equals to 8, and therefore BM equals to x, and therefore it equals to 8. This is line 7cm, this equals to 14 minus x. 14 minus x is 14 minus 8, that is 6. Likewise, QC also equals to 14 minus x, that is 6. So in the next step, we join points N all together by straight line. By joining points N O, we can do those two right triangles. We have the upper right triangle APO and the lower right triangle OCA. The upper right triangle APO and the lower right triangle OQA. So the area of this big quadrilateral APOQ in total must be equal to the sum of the areas of those two components that it consists of. And again, the area of the big quadrilateral APOQ according to the first method of calculation must be equal to the sum of the areas of those two components that it consists of. The first component is this right triangle APO, and therefore it is the area of the first component. It means that the area of the right triangle APO plus the area of the second component. The second component is the right triangle AQO. Therefore, it is the area of the right triangle AQO. So in total, we found out that the area of the big quadrilateral APOQ according to the first method of calculation must be equal to the area of triangle APA plus the area of triangle AQO. What is the area of this upper right triangle APO equals to the area of the right triangle APO equals to the base AP times the height PO over 2. And again, the area of the upper right triangle APO equals to the base AP times the height PO over 2. Plus the area of the lower right triangle AQO. The area of this lower right triangle AQO equals to the base AQ times the height QO over 2. And again, the area of the lower right triangle AQO equals to the base AQ times the height OQ over 2. Here AP equals to 16 plus 8, that is 24, times PO is R over 2. So total the area of this upper right triangle APO equals to 24 R over 2. So 24 R over 2. Plus the area of this lower triangle AQO. It equals to the base AQ. AQ in total is 18 plus 6, that is 24, times the height R. QO, that is R over 2. So total the area of this right triangle AQO equals to 24 R over 2. 24 R over 2. So in total the area of the big quadrilateral APOQ according to the first method of calculation equals to 24 R over 2 plus 24 R over 2. 24 R over 2 is 12 R. So we have 12 R plus 12 R, that is 24 R. So in total, we found out that the area of this big quadrilateral APOQ according to the first method of calculation equals to 24 R square inch in size. The next step, I deleted this straight line AO, and then we join points O and M together by straight line. Point O is the center of the circle, point M is the point on the circle itself, therefore OM is the radius of the circle, that is equals to R. The radius OM is equals to R, the radius OM is drawn to point M, that is the point of tendency BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. The next step, we join points O and B together by straight line, and we join points O and C together by straight line. When doing those constructions, we can do 4 right angles. 1, 2, 3, 4. So, we calculated the area of each of them separately, and then we did it together. The area of this right triangle OPB equals to the base PB, that is 8 times the height OP, that is R over 2. So in total, the area of this right triangle OPB equals to 8R over 2, that is 4R. Likewise, the area of this right triangle OBM equals to the base BM, that is 8, times the height MO, that is R2. So in total, the area of this triangle OBM equals to 8R over 2, that is 4R also. The area of this triangle OMC equals to the base CM, that is 6, times the height OM, that is R over 2. So in total, the area of this triangle OCM equals to 6R over 2, that is 3R. Finally, the area of this triangle OQC equals to the base or CQ, that is 6, times the height QO, that is R over 2. So in total, the area of this right triangle OQC equals to 6R over 2. 6R over 2 is 3R. So in total, the sum of the areas of those four triangles is equal to 4R plus 4R is 8R, 8R plus 3R is 11R, 11R plus 3R is 14R. So the sum of the areas of those four triangles is equal to 14 square units. So 14 square units. So, in the next step, we calculated the area of this big quadrangular APOQ according to the second method of calculation. The area of this big quadrangular APOQ according to the second method of calculation must be equal to the sum of the areas of those four right triangles, that's actually 14R, plus the area of this great triangle, triangle ABC. Repeat again. According to the second method of calculation, the area of the big quadrangular APOQ must be equal to the sum of the areas of the four right triangles, that's actually 14R, plus the area of the great triangle ABC. So we have to find out the area of this great triangle ABC. Actually, I presented to you a new formula that is true for the area of any triangle. Triangle ABC could be any triangle, and the area of triangle ABC that could be any triangle is as follows. It is equal to the square root of S times S minus 3 times S minus 3 times S minus 3. S is the semi-perimeter of the triangle that is area we are looking for. Again, S is the semi-perimeter of the triangle that is area we are looking for. What is the semi-perimeter? The semi-perimeter is the perimeter over 2. And the perimeter of any triangle equals to the sum of the side lengths of the triangle. The sum of the three side lengths of the triangle. In our case, it is 16. Triangle ABC, it is 16 plus 14 plus 18. So the perimeter of the triangle ABC equals to 16 plus 14 by, plus 18. And if we want the semi-perimeter, we have to divide the perimeter by 2. So the perimeter in total is 16 plus 14, that is 30, 30 plus 18 is 48. 48 over 2 is the semi-perimeter for triangle ABC. Those two sides, the equations are equal to each other, that is to say, the semi-perimeter of our triangle ABC is equal to 24 units in itself. The semi-perimeter of this triangle ABC is 24 units in itself. In this formula, A, B, and C are the side lengths of the triangle that its area we are looking for. So in our grand triangle, we choose A as 16, B as 14, and C as 18. And again, A equals to 16 according to our choice, B equals to 14, and C equals to 18. And the semi-perimeter of this triangle ABC is 24 units in itself. So we have all the data that is needed in order to find out the area of this grand triangle ABC. We just have to put the data inside this general formula for the area of any triangle. In this way, we find out the area of our triangle ABC. So we did it, and we found out that the area of the grand triangle ABC equals to the square root of S. S is 24 times S minus A. S minus A is 24 minus 16 times S minus B. S minus B is 24 minus 14 times S minus C. S minus C is 24 minus 18. So in total, we found out that the area of our grand triangle ABC equals to the square root of 24 times 24 minus 16 times 24 minus 14 times 24 minus 18. So the area of our grand triangle ABC equals to 24 times 24 minus 16. 24 minus 16 is 8 times 24 minus 14 is 10 times 24 minus 18 is 6. So in total, we found out that the area of our grand triangle ABC is equals to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression in total equals to 107.33 square roots inside. So we found out that the area of this grand triangle ABC is equal to 107.33 square roots in size. Therefore, we can substitute the area of this triangle ABC by 107.33. And therefore, this equation in total will be equal to, according to the second method of calculation, the area of the big quadrangle APOQ equals to 14R. That is the sum of the areas of the four right angles, four right small triangles, plus the area of triangle BC. That is 107.33 square roots in size. So this is the area of quadrangle ABC, of quadrangle APOQ according to the second method of calculation. But according to the first method of calculation, we already found out that the area of the same quadrangle APOQ equals to 24R square roots in size. So we have two different expressions for the area of the same quadrangle APOQ. Therefore, we can get equation 3 that says that the area of the big quadrangle APOQ according to the first method of calculation must be equal to the area of the same quadrangle APOQ according to the second method of calculation. The area of quadrangle APOQ according to the first method of calculation equals to 24R. It must be equal to the area of quadrangle APOQ according to the second method of calculation, and the area of quadrangle APOQ according to the second method of calculation equals to 14R plus 107.33. So in total, we found out that according to equation 3, 24R equals to 14R plus 107.33. If we subtract the 14R from this equation, we found out that 24R minus 14R is 10R. So 10R equals to 107.33. 14R minus 14R is 0. So left over we found 107.33. This side of the equation. So in total, according to equation 3, we found out that 10R equals to 107.33. Here we divide this equation 3 by 10, we found out that the radius of the circle, that is the radius that we are looking for this question, is equals to 107.33 over 10. 107.33 over 10 is 10.733 units in its length. And again, we found out in total that the radius of this circle is equal to 10.733 units in its length. So we finish to repeat on the solution of the first question. The next step, repeat on the solution of the second question. In the second question, our task is to find out the area of this shape. Okay, so in the drawing we have three semicircles. This is the biggest semicircle, this is the medium semicircle, this is the smallest semicircle. In addition, we have this rectangle. According to this given equation, the area of this rectangle is equal to 4 square inches in size, and we also have this quarter circle. Again, our task is to find out the area of this shape. So first of all, we define the length of this rectangle as x and the width as y. The width times the length times the width is the area of this rectangle. That is to say x times y equals to 4. X times y equals to 4. But we also know that the opposite sides of the rectangle are equal to each other. So in this rectangle, those two opposite sides are equal to each other. But this side is y. Therefore this side must be also equal to y. This is a quarter circle. Those two sides of the quarter circle are defined as the area of the quarter circle. The area of the quarter circle, therefore must be equal to each other and their radius. This radius is 1, therefore this radius is also 1. Actually, they don't look from the drawing you can say definitely that this length is longer than this length, but the problem is with the drawing. Actually, it is very difficult to do this drawing. Actually, if you look at the original drawing, you can see definitely that those two sides are equal to each other. When I drew the drawing, I didn't succeed to do it properly, so you should assume that those two sides are equal to each other. So therefore each of them equals to y. So we have here the diameter of this biggest semicircle equals to x plus y. Therefore the radius is x plus y over 2. So again, the radius of the biggest semicircle equals to x plus y over 2 units in its length. The radius of the diameter of this medium semicircle is x, therefore the radius is x over 2. And again, the radius of the medium semicircle equals to x over 2 units in its length. And finally, the diameter of this smallest semicircle is y. Its length is y. Therefore the radius is y over 2. And again, the radius of the smallest semicircle equals to y over 2 units in its length. Our task is to find out the area of this green shape. So what is the area of this green shape? From the drawing, it's very easy to see that the area of this green shape in total equals to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. And again, the area of this green shape, this is the area that we're looking at in this question, is equal to the area of the biggest semicircle minus the area of the minus the area of the medium semicircle minus the area of the smallest semicircle. The radius of the biggest semicircle is x plus y over 2. The radius of the medium semicircle is x over 2. The radius of the smallest semicircle is y over 2. So we just have to find out the area of each of those three shapes, the semicircles. This way we find out the area of the green shape. What is the area of the biggest semicircle? Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. So it is pi over 2 times the radius of the semicircle squared. The radius of the semicircle squared is x plus y over 2 squared. So total we shall know that the area of this biggest semicircle equals to pi over 2 times x plus y over 2 squared minus the area of the medium semicircle. The area of this medium semicircle equals to pi over 2 times the radius of this medium semicircle squared. The radius of this medium semicircle squared is x over 2 squared. So total, the area of this medium semicircle equals to pi over 2 times x over 2 squared. Minus the area of the smallest semicircle is equals to pi over 2 times the radius of this smallest semicircle squared. The radius of this smallest semicircle squared is y over 2 squared. In the next step, we simplify those three expressions. Here we have pi over 2. And we have x plus y over 2 squared. X plus y over 2 squared equals to x plus y squared over 2 squared. 2 squared is 4. Here we have minus pi over 2 times x over 2 squared. X over 2 squared equals to x squared over 4. Minus pi over 2 times y over 2 squared. So it is pi over 2 and y over 2 squared is y squared over 4. We have 8 in the denominator of all those three expressions, so we took 8 as a common factor, all those three expressions. And here, after we took 8 as a common factor, we have here pi times x in the denominator, pi times x plus y squared. This pi times x plus y squared. In the denominator, here we have minus pi x squared, and here we have minus pi y squared. So here I took complete here minus pi x squared minus pi y squared. So here we open the brackets of this expression, and we got that pi times x plus y squared equals to pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y. So this expression equals to pi times x squared plus y squared plus 2x times y. We have minus pi x squared minus pi y squared. We open the brackets here, so here we have pi x squared plus pi y squared plus 2 pi xy. And we have also minus pi x squared minus pi y squared. Pi x squared minus pi x squared is 0. Those two expressions get cancelled. Likewise, pi y squared minus pi y squared is 0. So those two expressions also get cancelled, and we have to leave with 2 pi xy in the numerator divided by 8. Here we divided both the numerator and the numerator of this expression by 2. 2 over 2 is 1, so in the numerator we left only with pi xy. And we have 8 over 2 is 4. So in total we found out that the area of the green shape equals to pi times xy over 4. But we only found out that xy equals to 4. So we can substitute xy by 4. Substitute xy by 4. I found out that this expression equals to pi times 4 over 4. We have 4 in the numerator, 4 in the numerator, so 4 will get cancelled, and we left only with pi. So in total, we found out that the area of this green shape, that is the area that we are looking for in this question, is equal to pi square root in its size. Okay, thank you very much.